The Newton is the international system of units derived unit of force. It is named after Isaac Newton in recognition of his work on classical mechanics, specifically Newton's second law of motion. See below for the conversion factors and SI unitizing. Definition: 1 Newton is the force needed to accelerate 1 kilogram of mass at the rate of 1 meter per second squared. In 1946, Conference Générale des Poids Mesures Resolution 2 standardized the unit of force in the MKS system of units to be the amount needed to accelerate 1 kilogram of mass at the rate of 1 meter per second squared. In 1948, the NITE CGPM Resolution 7 adopted the name Newton for this force. The MKS system then became the blueprint for today's SI system of units. The Newton thus became the standard unit of force in Le Système International d'Unités, or International System of Units. This SI unit is named after Isaac Newton. As with every international system of units unit named for a person, the first letter of its symbol is uppercase. However, when an SI unit is spelled out in English, it should always begin with a lowercase letter, except in a situation where any word in that position would be capitalized, such as at the beginning of a sentence or in material using title case. Note that degree Celsius conforms to this rule because the D is lowercase, based on the International System of Units. Section 5.2. Newton's second law of motion states that F equals ma, where F is the force applied, m is the mass of the object receiving the force, and a is the acceleration of the object. The Newton is therefore where the following symbols are used for the units: N, Newton kilogram, kilogram m, meter s, second. In dimensional analysis, where F, force m, mass L, length t, time. Examples: at average gravity on Earth, a kilogram mass exerts a force of about 9.8 newtons, and 1 newton is the force exerted by about half a medium-sized apple. 1 N equals 0.102 kilograms times 9.80665 meters per square second. The weight of an average adult exerts a force of about 550 to 800 N. 566 N equals 57.7 kilograms times 9.80665 meters per square second. 791 N equals 80.7 kilograms times 9.80665 meters per square second. Bench pressing 100 pounds takes a little under 450 N of force. 441 N equals 45 kilograms times 9.80665 meters per square second, commonly seen as kilonewtons. A newton is not much force, so it is common to see forces expressed in kilonewtons, or knots, where 1 kilonewton equals 1000 N. For example, the tractive effort of a Class Y steam train and the thrust of an F-100 fighter jet are both around 130 kilonewtons. Where units are commonly in kilonewtons, a common rule of thumb is to multiply the kilonewton value by a factor of 100 to get the kilograms. 1 kilonewton is 102.0 kilograms force, or about 100 kilograms of load. 1 kilonewton equals 102 kilograms times 9.81 meters per square second. So for example, a platform rated at 321 kilonewtons will safely support a 32,100 kilograms load. Specifications in kilonewtons are common in safety specifications for the holding values of fasteners, earth anchors, and more, in the building industry. Working loads in tension and in shear, rock climbing equipment, clamping forces of the various molds in injection molding machines used to manufacture plastic parts. Conversion factors.